Algebra 2, lesson 4.4b, factoring polynomials in quadratic form. Okay, so let's take a look at number 1 here. So you notice that if we were to factor this is just a trinomial with a, b, and c, right? So we learned how to factor this using the x method, right? A times c is 24, b is negative 10. So it looks like we'll have negative 4 and negative 6. That's our two values here. Divide by 1. So our factors will be x minus 4, x minus 6, right? Now let's say you get a problem like number 2. So this is not a quadratic because it's not x squared, right? But what you have to do is you have to kind of recognize that it kind of looks like a quadratic, right? It's what we call in quadratic form. Because if we actually just treat this like a quadratic, so if you kind of pretend this is still a, b, and c, so if you do a times c, we get 24. We're trying to get negative 10 in the middle, and so that'll be negative 4 and negative 6, and we're dividing by 1 still. So everything you notice is still exactly the same, right? So, but then the only thing different is since this is x to the 4th, we're going to need a x squared minus 4, and this would be an x squared, right, minus 6, right? And if we actually multiply all this out, if you actually FOIL this and multiply it out, you're going to notice you're going to get the original problem, which means that yes, we are able to factor this using the x method, because this polynomial, even though it's not technically a quadratic, is what we call in quadratic form, right? If it's in quadratic form, we can still factor it using the x method. Okay. One thing you have to be careful though, you should notice that this x squared minus 4, this is a difference of squares. I can factor this more, right? So if I factor this more, it's going to be x plus 2, x minus 2. Now the x squared minus 6, I can't factor this more, so I would just leave it like this. And this would be our complete answer, right? Fully factored. Okay? So whenever you can factor more, you always have to double check, right? And make sure you factor more if you can. Okay? Number 3 here. So if we recognize this problem, right? This was what we called a difference of squares, because we can get the problem to fit this format right here, right? So this would be 2x, this would be 3. So our factors were 2x plus 3 and a 2x minus 3, right? Number 4 here, you have to recognize this is also a difference of squares, right? It's just that this is not x squared, it's x to the 4th. But it's still a difference of squares because we can get it to fit this format here. So this would be 4x squared, this would be 9. So our factors would be 4x squared minus 9 and 4x squared plus 9, right? Then you have to recognize 4x squared minus 9. This is also another difference of squares because I can get this to fit this format right here. So this would factor out to 2x plus 3, 2x minus 3, and then I have to bring down the 4x squared plus 9 as part of my answer still. So this would be your answer completely factored out. Okay? So let's take a look at some more examples to factor. Okay? So remember, when we're factoring, we're still always looking for a GCF. So number 5 here, I do recognize the GCF. So I'm going to take that out. It's going to be 2, right? So I get 2x to the 4th minus x squared minus 3, right? Then I recognize this looks like it's in quadratic form. I've got this x to the 4th here, and then this is x squared in the middle, okay? So I'm going to try and factor this using the x, right? So a times c, right? That made negative 6. B is negative 1, right? Pretend this is a. This is b right here. This is c. So what numbers work? Let's say, hey, negative 3, positive 2. If I multiply, I get negative 6. If I add, I get negative 1. I have to divide by a, which is 2. Looks like I can reduce this fraction. This will reduce to 1 over 1, right? So it looks like my factors will be 2x. Now remember, this is 2x to the 4th. So we need to have a 2x squared minus 3. And then we have that x squared plus 1, right? And bring down our GCF. Now you want to double check, can I factor any of these more? So these binomials, you want to double check to see if they might be a difference of squares. They are not, so we know that we are done. Okay, let's take a look at number 6 here. So there's no GCF, right? Now I've got an x to the 4th, right? And then an x squared in the middle. So it looks like that's in quadratic form, so I'll factor this using the x. A times c, negative 12, b is negative 1. Looks like I've got negative 4 times 3, right? Divided by a, which is 1. So my factors are going to be x squared minus 4, x squared plus 3. I can factor the x squared minus 4 more. That's going to be x plus 2, x minus 2. Then I have the x squared plus 3. That's my complete answer factored out. Okay. Alright, so let's take a look at the next example here. So number 7, if I want to factor this, so I notice first of all there's a GCF, and since I want a to be positive, I'm going to take out a negative, right? So it looks like I'm going to take out a negative 4. So then that's going to leave me with 2x to the 4th minus 7x squared, and then plus 6, right? And then this would be my A, my B, and my C. So this looks like it's in quadratic form. I've got the x to the 4th here and an x squared in the middle. So I'll factor it using the x. A times c, that gives me 12. B is negative 7. So it looks like negative 3 times negative 4. That'll work for me. Divide by a, which is 2. I can reduce this fraction. This reduces negative 2 over 1. So my factors are going to be 2x squared minus 3 and x squared minus 2 in my GCF. Can I factor these binomials more? I cannot, so I know I'm done. Okay. Number 8 here, right? This looks like it could be a difference of squares. It's a binomial. There's a minus in the middle. So let's see if I could get it to fit our format. So it looks like I can make this 2x to the 4th, right? Because that would give me x to the 8th. Then that would be 5. So then I'll have 2x to the 4th minus 5. 2x to the 4th plus 5. Can I factor these more? I can't, so it looks like I'm done. Okay. Let's look at number 9, right? So there's no GCF. Alright, it looks like it's in quadratic form, so I'm going to try the x. I'll factor it using the x. A times c is 64. B is negative 20, right? So what multiplies to give me 64 and adds up to give me negative 20. Well, I've got negative 16, right, and negative 4. If I multiply, it gives me positive 64. If I add them, I get negative 20. Divide by a, which is 1. So it looks like my factors would be an x squared minus 16, x squared minus 4. And then I have to recognize both of these are difference of squares, so I can factor both of these more. This is going to be x plus 4, x minus 4. This is going to be x plus 2, and x minus 2. Okay. Over here I notice a GCF, so I've got to take out the GCF, right? So anytime there's a GCF, remember to take it out. Then I end up with x to the 12th minus 4. And then it looks like, hey, I can get this to fit our format for a difference of squares. This would be x to the 6th, and this would be 2. So then our factors are going to be x to the 6th plus 2, x to the 6th minus 2. My GCF is 4. Now this x to the 6th minus 2, is that a difference of squares? No, it's not. So it looks like I'm done. Okay.